Hello, Maurits here. This video is about the mass spectrometer. And mass spectrometer is basically a machine that separates particles depending on their mass. So for example, if one want to analyze some chemical substance or something, we could separate the molecules or the atoms in some way depending on the mass. So the first thing we need to have is some kind of thing where you can throw out the molecules or the atoms, and we see to that we strip away one of the electrons on the way out. So we, in some way, actually we do that over here. We strip it away, and then we see to that this end is negative, so they will be accelerated through here. So we throw out particles here. They will have different velocities and so on, but they will in some way move in that direction. And we'll let them go through a uniform magnetic field. And if we do so, we will see that, okay, the field is in this direction, they are moving, so the field is in this direction, the particles are moving that direction, so that is the current, the positive particles, and that means that we have a force going upwards, and when the particle is inside here, they move in that direction, and we'll have a force in that direction due to magnetism. And that means that it curves over here. The problem is that if we remember the formula for the radius in a magnetic field, we have that the radius equals to mv over qb. So on one hand it's depending on the mass, which we want, but it's also depending on the velocity that we don't want to have. The charge is 1 plus 1, so that is the same, and the field we decide is what field strength we have, so that's no problem. But the problem is that the separate different velocities that you might have here. So up to solve this, they come up with a trick. We put two plates here that we have a voltage on. We put this to be positive and this to be negative. So that means that you also have a repulsive force on that, an attractive force on that, and that means that you have, this is magnetic force, you have an electric force pointing downwards. And we have for the magnetic force, we have the formula VQB, right? And since the electric field is defined as force over Q, we have that the electric force equals to E times Q. If we put these to become equal, they will opposite direction, but we put them equal in strength, we get that VQB equals to EQ. And the Q and the Q will cancel, and that means in the end that the velocity will be E over B. So the velocity of the particles for which these two will balance will be all the same. It hasn't to do anything with the charge. It won't have anything to do with the mass. Actually, you need to have some charge, but how much you have doesn't matter, and what mass you have won't matter. So all the particles that go straight through here will have the same velocity. What we do now is we put some kind of screen here with a little hole in, and out from this will pop particles, all of them having the same velocity. Then we let this go through a magnetic field, a uniform magnetic field again. And now only the magnetic field would work on this. So now they will have field of force in that direction, and according to this formula we know that this is the same for all the particles. The charge is plus 1 for all of them. B is the same, since we have decided for the value of that. The only thing the radius will depend on is the mass, and then the radius will be bigger masses. So if you put some kind of detector screen here, we can see that the bigger masses will have bigger radii, and the lighter ones will turn quicker. So here we will have that heavier masses will be further down here, and smaller ones there. And if you have some kind of detector, this could actually be some kind of photographic film, then you will get some kind of pattern, and then we can decide, okay, we know by the construction that this might be one isotope of carbon on this and another, so this might be carbon 12 and that might be carbon 14 or something like that. And the size of the peak will then determine how much of these substances we have. So this is an application of what we have looked on so far. Rather cool, I must say. Thank you.